This is the video for 2.2, which is solving inequalities involving addition and subtraction. So solving an inequality is very similar to solving an equation. The only difference is that you have an inequality symbol instead of an equal sign. But we're still using inverse operations. Our goal is still to isolate the variable. So on your notes, you have these core concept inserts, which just remind you of our addition property, only this time it's the addition property of inequality. And what that means is that you can add the same number to both sides of an inequality, and the inequality statement will remain true as long as you do the same thing to both sides. Okay? So let's go ahead and look at the example that we did on our notes today. So we have x minus 6 is greater than or equal to negative 10. So I'm just pulling this down here where I have a little bit more room to solve. Okay? So just like when you're solving equations, what you want to do is you want to do the opposite of what they're doing. So if you notice right here we have x minus 6. If we want to get x isolated or by itself, the opposite of subtracting would be to add 6 to both sides. So I'm going to add 6 to both sides, and when I do that, my positive and negative 6 are going to cancel. I bring down my x, I bring down my inequality symbol, so we have x is greater than or equal to, and then negative 10 plus 6 is negative 4. Now, we've been talking for a couple of days now about inequalities, and remember, an inequality has multiple solutions. So what this is telling me is that x can be any number that's greater than or equal to negative 4. So I can plug in a negative 4 right here. Negative 4 minus 6 is greater than or equal to negative 10 because it actually equals negative 10. If I pick any number that's bigger than that, it's going to work. So this is one way to express our answer as an inequality, but you might also see it graphed on a number line. So remember, we did graphing in class. It was 2.1. It was our first lesson. So I'm going to just make us a number line right here, and I'm going to graph that solution. Now, if a number line is not given to you, you guys should be able to make one for yourself. So I have greater than or equal to. That means that would be a closed dot. That's a review from 2.1, closed dot because it's equal to. And then my ray should be pointing to the right because that's where all the numbers that are bigger than negative 4 would lie on the number line. Okay? So just like with solving equations, we know that the opposite of addition, or the inverse operation, would be to subtract. So once again, I'm going to pull this one down here, and we have y plus 8 is less than or equal to 5. So if we are trying to get y by itself, we want to do the opposite of adding 8, which is to subtract 8 from both sides of this inequality. When I do that, positive and negative 8 cancel, and I bring down my y. I bring down my inequality symbol, so y is less than or equal to, and then 5 minus 8 is negative 3. So this would be the first part of my answer, but notice right here it also asks me to graph my solution. So I'm going to draw a number line. I am going to make sure that negative 3 is on there and some other values. And since this is less than or equal to, once again, I have a closed dot on negative 3, but the numbers that are less than or equal to that would be to the left of that on the number line. So my ray points left. Okay, why don't you go ahead and pause and see if you can solve B. Don't forget, we talked about on Monday that if the variable is on the right side after we solve, we want to make sure we move it to the left. So go ahead and pause and see if you can do that and graph the solution, and then you can check your work with mine. Okay, so for this one, the opposite of positive 1.4 was to subtract 1.4. So those will cancel, and negative 8 minus 1.4 is negative 9.4. I brought down my inequality and I brought down my variable. However, I am trying to compare m to negative 9.4, so I moved m, which meant I had to flip my inequality because I want to write it, backwards basically. M is greater than negative 9.4. So that's what I have here. So that's my answer. Then to graph that, since it is just greater than, we have an open circle on 9.4, which is a little less than halfway between negative 9 and 10. And then my arrow is pointing to the right because that is where the numbers that are greater than negative 9.4 would be on the number line. So then we had a word problem. So let's look at the situation we've got going on here. It says a circuit overloads at 1800 watts of electricity. That means that you can only have 1800 watts or less. If it overloads, that would be bad. Okay? So you plug a microwave oven in that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading it. So the key here is that we do not want to overload. It says without overloading. So we know that we already have 1100 watts in the circuit. We can add some number to that as long as it is less than or equal to 1800 watts because it tells me up there that that's the maximum amount. Okay, so we wrote our inequality. That was step one. Then it also asks me to solve that. So the opposite of positive 1100 would be to subtract 1100 from both sides. When I do that, positive and negative will cancel. I bring down my x. That's going to be less than or equal to 700 watts of electricity. So we have accomplished answering this first problem up here. Okay? So then it says, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading? So on our notes, I gave you some items on the screen, and we talked about that. So obviously we wanted to make sure that all of the numbers that produced less than or equal to 700 watts were okay to plug in. Okay? So we used that same information to answer this next part. If you have any questions about either of those from your notes after you review it, you can always ask me in class or you can come in for tutoring. So on 2.1 we translated some inequalities, but now we are going to be writing and solving an equation. Notice this says equation. So this is a little bit of review from chapter 1. Okay, so looking at number 1, it says the difference of twice a number and 9 is 15. So difference means that it's a subtraction problem. We know we have twice a number, so that would be 2x minus, and then it says and 9. So 9. The word is what tells you this is an equation and not an inequality. So that would equal 15. Okay, you should be able to solve this equation. We worked on solving equations for 3 weeks, and what we're doing right now is very similar. So I want you to pause and see if you can solve this one on your own. Okay, so the first thing that I did was, since I'm trying to get x by itself, the opposite of subtracting 9 was to add 9 to both sides. 15 plus 9 is 24. Then I brought down my 2x. The opposite of multiplying by 2 is to divide by 2, so 24 divided by 2 is 12. So I know that x has to be equal to 12. Alright, let's go ahead and translate 2, 3, and 4 together, and then I'll see if you guys can solve those on your own. Alright, so for number 2, we have the sum. So I know that that's the answer to an addition problem. So it says 4 times a number, so that's 4x. If I want the sum, that's addition, and 1. So 4x plus 1 is negative 7. Okay, so we translated number 2. Let's look at number 3. It says 3 times the difference of a number and 8. So this is when you are looking at, are we using parentheses? Do they want me to find the difference of two things and then multiply it by 3, or what's going on? And the key word here is, since they used difference, I know I need to subtract first. Well, the only way to make that happen is to put a number and 8, the difference of a number and 8, so that's x minus 8, inside parentheses. Then I want to do 3 times that amount, and that is 12. Okay, so 3 times the difference of a number and 8. So the difference of a number and 8 times 3 is, that's your equals, 12. Alright, so let's go ahead and look at number 4. So we have the quotient. Remember, quotient is the answer to a division problem of 4 minus a number. So we have 4 minus a number, and we want the quotient, so that's division, and negative 9 is 2. Okay? So we've translated 3 equations. Why don't you go ahead and pause and solve those, and then you can check your work with mine. Remember, this is a review from Chapter 1. The reason we're doing this is to get you prepared for what we're going to be doing later this week, which is solving multi-step inequalities. Okay, so I have solved all 3 equations. For number 2, you should have gotten that x is equal to negative 2. For number 3, x is equal to 12. And then for number 4, x is equal to 22. I want to talk about number 4 because I noticed that you guys are still having a little bit of trouble with the ones that are looking like fractions. So our original equation was 4 minus x divided by negative 9 equals 2. The opposite of dividing by negative 9 is to multiply by negative 9. When I do that, negative 9 over negative 9 will wind up canceling out, and I'm left with 4 minus x. And if I multiply by negative 9 on the left, I have to do the same thing on the right. So that's why I did 2 times negative 9 is negative 18. Then from there, the opposite of positive 4 was to subtract 4. That's where the negative 22 came from. But x was still negative. So to get rid of that minus x, I divided by a negative 1. Because remember, this is like negative 1x. So when you divide both sides by negative 1, you find out that x is 22. Okay. So there were 2 things that we talked about in this video. One was solving addition and subtraction inequalities, and then these last 4 problems were reviewing solving 2-step equations, or multi-step, since this one had distribution and this one was 2-step. If you have any questions about either of those things and this video is not enough support to help you, please make sure that you come in for tutoring so that you don't fall further behind in class, because we will be building on these skills. You guys have a fantastic night.